Hello students, how are you all? I hope you are doing absolutely fine. So welcome all of you at AriserTalent, and I am your chemistry teacher Krina Dayani, and we are discussing about the chapter first of the class 9 chemistry, that is matter in our surroundings, and we are about on the last part of the chapter, that is about the evaporation and its application in our day-to-day life. Now before starting the evaporation, let's see the general things around us that are related to evaporation. Now, you have usually heard about the term that what actually the evaporation is in your lower classes, because this term has been started from your 5th or 6th standard, I guess. So, we have to study the evaporation and its effect to a wider level in our class 9th topic of the chemistry, and this topic is quite interesting, and you will see that it is our applications in daily life that we have recognized very easily. So let's start here. You have seen that whenever we put a wet clothes in the summer, they dry up very quickly, because in summer the sunlight is there and the rate of evaporation is very fast. But what happen in the rainy day when you dry your clothes in a rainy day? In rainy day, there is a lot amount of moisture in the atmosphere, and whenever there is a moisture in the environment, the rate of evaporation will go on decreasing very fastly. So these clothes will not dry up very quickly as they are going to dry in the summer. So this is the application of evaporation in our day-to-day life. Now you see that we generally wear cotton clothes in summer. So why are we wearing cotton clothes in summer? Why we are not wearing the synthetic clothes? Because the cotton clothes have a tendency to absorb our sweat. If they are absorbing our sweat, this sweat will going to evaporate very fastly and provide the cooling effect to our body. On the other hand, synthetic fibers do not have a tendency to do so. So this is the second application, that why we are wearing the cotton clothes in summer. Now the third application, you have seen that in a dry sunny day, you generally sprinkle water in the balcony or the ground or in the lawn you have provided in your homes. So why we sprinkle water? Because in a hot sunny day, there is a very much heat, or there must be very hot outside. So just sprinkling the water, what will happen? The rate of evaporation increases. This water will evaporate very quickly and provide the cooling effect there. This will provide a cooling effect on the surface. So generally you can see that when evaporation is done, heat is supplied to the system. So you can also ask me, ma'am, in boiling we also supply the heat to the system and the water evaporates very quickly. But students, this boiling and evaporation is not the same phenomena. We will discuss now that what is the basic difference between the boiling and evaporation. So let's start the chapter here. Let's start the last topic of the chapter here, that is about evaporation. So evaporation. So firstly, what is the definition of evaporation? Evaporation is a phenomena in which a liquid converts into vapor, but the condition is the temperature must be below its boiling point, because at the boiling point the water will start boiling. So the temperature you have to keep is below the boiling point, and it is basically the surface phenomena. It means it is always going to occur on the surface. It is not going to occur in the bulk of any liquid. It happens only at the surface, and the temperature you have to keep the temperature below its boiling point. This is a very important term that you have to write in your definition here. So the phenomena of converting water into water vapors below its boiling point at the surface of any liquid is known as evaporation. So this is the definition of evaporation, and it is very, very important. And one thing you have to keep in your mind, that the temperature must be below its boiling point, and it is a surface phenomena we have. So this is the definition of evaporation we have. Now let us move to the explanation of the evaporation. Now I have said you that evaporation is a surface phenomena. It means it basically occurs on the surface of the liquid we have. So what will happen here, the particles on the surface of the liquid, there are so many particles we have, but all the particles do not have a equal kinetic energy. Some particles will have a high kinetic energy and some particles will have a low kinetic energy. So what will happen there, the particles of high kinetic energy will going to evaporate very quickly, and the particles of the low kinetic energy will remain on the surface, and they will going to constitute the effect on the liquid. It means evaporation is going to provide you the cooling effect. So whenever you keep the temperature of a liquid below its boiling point, this liquid will going to vaporize very quickly, and the particles with high kinetic energy will going to evaporate very quickly, and the low particles will remain on the surface of a liquid. So it means kinetic energy is also an essential factor in the evaporation. Now what will happen, if you keep on increasing the temperature of a liquid, the particles will evaporate very quickly. So it means it depends upon the surface, it is also going to depend upon the temperature of a liquid. So it is a surface phenomena in which kinetic energy is also involved, and the factor of the temperature is also involved here. Now let us discuss the part or the factors on which the evaporation is basically depends upon. So our next discussion is about factors on which evaporation depends. So evaporation is basically going to depend upon the 5 factors we have. First one is nature of liquid. Second one is wind speed. Third one is surface area. Fourth one is temperature, and the last factor will be humidity. So these are the several factors on which the rate of evaporation is going to be depend. So first one is about the nature of liquid. Second is about the wind speed. Third is about the surface area we have. Fourth factor is temperature, and the fifth one is about the humidity. So there are several factors on which the rate of evaporation depends. Now we will deal with all these factors one by one, that what will be the effect of evaporation on increasing or decreasing such kind of the factors. So firstly we will discuss about the nature of liquid, but before that you can copy it from here so we can proceed to our next part. So now let us discuss some of the factors here. So firstly we are discussing about nature of liquid. So first factor is about nature of liquid. Now, how evaporation is going to depend upon the nature of liquid we have. Now, if we have the different liquids having the different intermolecular separation between them. Now, if the intermolecular separation is very high in one liquid and it is very low in other liquid, then the particles will having the large intermolecular force of attraction will going to evaporate very quickly. It means the nature of the liquid is also going to decide whether the rate of evaporation will be high or low. So, we can conclude from here that if intermolecular distance is high, rate of evaporation is also fast. अगर इंटरमॉलिक्यूलर डिस्टेंस पार्टिकल्स के बीच में ज़्यादा होगा तो रेट ऑफ इवेपोरेशन भी बहुत ज़्यादा फास्ट होगा. सो लेट अस टेक एन एग्जांपल हियर. यू हैव हर्ड अबाउट द एसीटोन इन योर डे टू डे लाइफ. एसीटोन इज जस्ट अ नेल पॉलिश रिमूवर दैट वी यूज टू रिमूव द नेल पॉलिश फ्रॉम आवर nails. Now, when you place this acetone in your palm, you can see that at the room temperature, this acetone will going to evaporate very quickly and leaving behind your palm very cool. So, this phenomena is basically related to the nature of the liquid. Similarly, if you keep water or any other liquid in your hand, it will not going to evaporate very quickly. So, we can say that intermolecular distance between the particles is an essential factor for determining the rate of evaporation here. So, if the intermolecular distance between the particles is very large, we can say that this will evaporate very quickly. So, we can write an example here. Example is acetone. Example we have is acetone when kept in a palm it evaporate very quickly. So, this is one of the application of the evaporation we have seen here. So, this is about the nature of the liquid. Second factor is about the speed of the wind. Now, how will the speed of a wind going to determine the rate of evaporation? Now, our second factor is about wind speed. Now, rate of evaporation will be directly proportional to the speed of the wind. It means higher the speed of the wind, higher the particles of the vapor will be carried away from the atmosphere and higher will be the rate of evaporation. So, I can write here that wind speed is directly proportional to, or we can say that evaporation is directly proportional to wind speed. So, the rate of evaporation will be directly proportional to wind speed. Now, how we can understand that how the rate of evaporation will be directly proportional to the wind speed? Let us consider the example here. Now, what will happen? You have seen that if you going to dry your clothes in a summer, if there is a very much heat from the sun, the clothes will dry up very quickly. But what you observe that on a windy day, when the speed of the wind is very high, it means जब speed wind की बहुत ज़्यादा होगी तो you can observe that कि अगर wind की speed कम है तो हमारे जो क्लोथ्स होंगे वो क्विकली ड्राई नहीं हो पाएंगे। एंड अगर विंड की स्पीड बहुत ज़्यादा है तो क्लोथ्स जो होंगे वो बहुत ईजिली और फास्टली ड्राई हो जाएंगे, जो वेट क्लोथ्स होंगे। तो इट मीन्स जब अगर विंड की स्पीड ज़्यादा होगी तो उस केस में एटमॉस्फेयर में इवेपोरेशन का रेट भी क्या होगा, फास्ट होगा। तो इसका एग्जाम्पल हम क्या कंसिडर कर सकते हैं, एग्जाम्पल वी हैव drying of clothes in a windy day. It means when the speed of a wind is very fast, the rate of the evaporation will also be very fast. Now the next factor on which the rate of evaporation is going to be depend will be surface area. Now the third factor we are considering here will be about the surface area. Now what is the relation between the rate of evaporation and the surface area? Let's discuss here. Now the rate of evaporation is again directly proportional to the surface area. It means more will be the surface area, more will be the rate of evaporation, less will be the surface area, less will be the rate of evaporation. So I can write here, again rate of evaporation is directly proportional to surface area. Now, how these factors are related to each other, let us consider one more example here. You have seen that when you just keep the clothes just by contracting with each other and you go and dry them in a wet clothes in a dry season, you will see that the clothes will not get dry very quickly. But when you spread the clothes, they will going to dry very quickly, because as the surface area increases, the rate of evaporation is also going to increase. It means अगर हम क्लोथ्स को पूरा स्प्रेड करके अगर एनवायरनमेंट में हम उन्हें वेट क्लोथ्स को ड्राई करेंगे तो हम ये देखेंगे कि जो कपड़े पूरी तरह से ओपन होंगे, इट मीन्स जिनका सरफेस एरिया बहुत ज़्यादा होगा, तो वो क्लोथ्स जल्दी सूख जाएंगे। वो जल्दी क्यों सूख जाएंगे? क्योंकि उनमें सरफेस एरिया इंक्रीज होते ही क्या बढ़ जाएगा, रेट ऑफ इवेपोरेशन बहुत ज़्यादा बढ़ जाएगा। तो वन एग्जाम्पल वी कैन सी हेयर दैट वी ऑलवेज स्प्रेड द क्लोथ्स बिफोर ड्राइंग दैम। Second example, you can see that if you want to sip a tea, just when the tea is very hot, you can't sip a tea as frequently we used to drink the tea. So you can use a saucepan, or you can take any china plate to drink that tea. Now what will happen if you drink a sip from a cup of tea? It is very hot, but when you spread it on a saucepan or in a china dish, you can see that the tea you are drinking will cool very quickly. It means अगर हम एक कप में चाय को लेके अगर हम ड्रिंक करते हैं तो वो जो टी होती है वो बहुत गर्म होती है और वी कांट सिप अ टी वेरी फास्टली, बट व्हेन यू स्प्रेड इन अ प्लेट और अ सॉस पैन, यू कैन सी दैट जो चाय है वो ठंडी हो जाएगी एंड इट बिकम पॉसिबल कि हम उसको ड्रिंक कर पाएँ। सो इट मीन्स जैसे ही हमने उस लिक्विड का, उस टी का सरफेस एरिया इंक्रीज किया, रेट ऑफ इवेपोरेशन भी क्या हो गया, बढ़ गया, और उसने क्या किया, उस चाय के ऊपर अपना कूलिंग इफेक्ट छोड़ दिया। तो इसका मतलब जैसे हम सरफेस एरिया को इंक्रीज करेंगे, रेट ऑफ इवेपोरेशन भी क्या होगा, बढ़ जाएगा। तो इसका जो एग्जांपल है हम कंसिडर कर सकते हैं, एग्जांपल वी हैव, फर्स्ट एग्जांपल वी हैव, वी स्प्रेड वेट क्लोथ्स before drying them, and secondly, when we drink a hot tea, we generally put it in a saucepan. So ये जनरल एग्जांपल्स हैं जो कि कैटेगरी को कैटेगराइज करते हैं अबाउट द सरफेस एरिया. नाउ जो नेक्स्ट फैक्टर है हमारा ऑन विच द रेट ऑफ इवेपोरेशन इज गोइंग टू बी डिपेंडेंट इज अबाउट द टेम्परेचर. Now what will happen if you keep increasing the temperature of a liquid? You know that when the temperature of any liquid is increased, the kinetic energy of the molecules will increase automatically. When the kinetic energy is increased, they will leave the surface very quickly, leaving behind the surface very cool. So whenever the temperature is increased, the rate of evaporation is again increased. So our fourth factor is about temperature. Now again rate of evaporation will be directly proportional to temperature. It means whenever the temperature is increased, rate of evaporation will automatically increase. Now whenever the temperature is increased, the rate of evaporation will increase. What is the example for the increase in temperature? When you sprinkle the water in an open ground in a hot sunny day, it will dry up very quickly, leaving behind the surface very cool. It means the temperature is high, sun rays are falling on that ground, so the rate of evaporation is very high when you just sprinkle the water on the surface. So its example we can consider here is sprinkling of water in a hot sunny day. It means it will leave the ground very cool after some time because the rate of the evaporation increases as you just increase the temperature. Now the last factor we are going to discuss about the factor on which the rate of evaporation depends is about the humidity. Now what is humidity? Have you heard the term humidity? Now humidity is basically the amount of moisture that is present in the atmosphere. Amount of air, amount of moisture air में कितना है वो determine करेगा कि climate कितना ज़्यादा humid है. अगर amount of moisture ज़्यादा होगा it means जो humidity है वो ज़्यादा होगी and we will feel much warm in that area. It means in rainy days you have seen that in rainy days we feel more amount of sweat in our body because the humidity is very high in case of the humid season. Now humidity will be inversely proportional to rate of evaporation. It means अगर environment में humidity ज़्यादा होगी तो rate of evaporation क्या हो जाएगा, कम हो जाएगा. तो it means अगर हमें rate of evaporation को increase करना है तो humidity को क्या करना पड़ेगा, कम रखना पड़ेगा. तो it means humidity will be inversely proportional to rate of evaporation. So we can say that humidity will be inversely proportional to rate of evaporation. This is the inverse relation we have described. You can see that humidity will be inversely proportional to rate of evaporation, and humidity is what? It is the amount of moisture that is present in the atmosphere. Now let us take an example here. Just as we have the 2 days, one day is in rainy season and one day is a normal day we have. Now when you are given the wet clothes, what you can see that अगर हम wet clothes को समर में सुखाएंगे और हम अगर उसको रेनी डे में सुखाएंगे तो नॉर्मल डे में वो क्लोथ जो है वो बहुत क्विकली ड्राई हो जाएगा. वो क्यों ड्राई हो जाएगा? क्योंकि उस टाइम पे एटमॉस्फेयर में ह्यूमिडिटी कम है. तो इसका मतलब रेट ऑफ इवेपोरेशन क्या है, ज़्यादा है, क्योंकि जो ह्यूमिडिटी है वो रेट ऑफ इवेपोरेशन की इन्वर्सली प्रोपोर्शनल है. इट मीन्स अगर एक फैक्टर इंक्रीज करेगा तो दूसरा फैक्टर ऑटोमेटिकली क्या करेगा, डिक्रीज करेगा. देन अगर हम उन्हीं क्लोथ्स को रेनी डे में सुखाएंगे तो हम ये ऑब्जर्व करते हैं कि जो बारिश में हमारे क्लोथ्स होते हैं वो जल्दी ड्राई नहीं हो सकते, क्योंकि उस टाइम पे क्या है, एटमोसफियर में देयर इज़ अ लार्ज अमाउंट ऑफ मॉइस्चर प्रेजेंट. इट मीन्स इफ देयर इज़ अ high amount of humidity, the rate of evaporation will going to be decrease simultaneously. So this is the factors we have discussed on which the rate of evaporation is basically dependent upon. These factors are very important because the reason type questions, the questions in your exam that are from the reason based theory will be asked from such type of the topics. Now it basically depends upon the nature of liquid, wind speed, surface area, temperature and humidity. So the only factor which is inversely proportional is humidity, and all the other factors are directly proportional to the rate of evaporation. So these are some of the factors. This is very important because the reason type questions can be asked from this topic only. So firstly, copy this theory from here. So now these are the factors on which rate of evaporation is dependent. Now we will see how will be the cooling caused by evaporation. So the next topic is about cooling caused by evaporation. Now the question arises that how will be the cooling effect of evaporation will take place. Now you know that whenever evaporation take place, it will always drawn, it will evaporate only because it will take a latent heat from that substance. Suppose I am placing the acetone in my palm, you can see that acetones vaporize very quickly and it will leaving behind my palm very cool. It means it has drawn the latent heat from my hand and from the environment we have. Now latent heat is the amount of energy that is we have discussed that is in the hidden form present in the substance, and it is the amount of energy in which there will be a fusion, latent heat of the fusion we have discussed and the latent heat of the vaporization we have discussed. So this energy is in the hidden form which is used for the interconversion of the particles. It means interconversion of one state to another. It means whenever anything evaporates, it always takes out the latent heat from that substance. So we can say that cooling effect is based on the fact that whenever a liquid evaporates, it draws or takes latent heat from that substance. It means अगर कोई भी चीज़ कूल होती है तो वो क्यों होती है, क्योंकि एनवायरमेंट से या उस सब्सटेंस से वो लेटेंट हीट को एब्जॉर्ब कर लेती है. सो द फैक्टर बिहाइंड द कूलिंग इफेक्ट ऑफ इवेपोरेशन is only the latent heat. Now let us see the example of the cooling effect of the environment, cooling effect of the evaporation we have seen. We have seen these examples, but let us revise once more. So which examples we can conclude from this? So the first example we have in this sequence is The cooling effect is caused by evaporation, that is we wear the cotton clothes in summer. So first application is that we wear cotton clothes in summer. So this is the one of the effect of cooling effect of evaporation. Second example we have cooling effect observed when we place acetone in our palm. Cooling effect is felt when we put acetone in our palm. And the third effect we can observe there is that we can see that when we sprinkle the water in a hot sunny day, we can see that the ground will cool very quickly. So the third application is about sprinkling of water in a hot sunny day. So these are few of the examples we have considered in the cooling effect caused by the evaporation. So we have discussed that whenever a liquid evaporates quickly, it will always draw the latent heat from a substance. That's why the cooling effect is possible. And whenever the particles that are present on the surface, they have the high kinetic energy. So the high kinetic energy particles will vaporize very quickly, leaving behind the low energy particles. So that's why we can say that evaporation is basically a surface phenomena. Now, before discussing many more applications of the evaporation, we will define or distinguish the two terms, that is evaporation and boiling, and it is very essential to know the difference between evaporation and boiling so you can't confuse between these two terms. So let's discuss about the differentiating points between boiling and evaporation.